one step, and I'm going to put in here addition and subtraction inequalities.
You said inequalities?
Inequalities. I'm also going to go ahead and tell you the first key point for today immediately, and that is that solving inequalities is the same as solving equations. And then I'm going to put a comma and I'm going to put an except. We're not going to worry about this except today. We're going to worry about that tomorrow. But I don't want you to have an idea in your head or not realize when we get to it later that there is going to be something that is going to be ever so slightly different. One thing that we have to worry about, but we're not going to worry about that today. All right, so we're looking at this. We have this first inequality. We have x plus negative 4 is greater than 9. So if our first key point is that we are supposed to solve this just like we would solve an equation, what do you think the first thing we need to do is to solve this inequality? Viviana. Add a positive 4 to both sides. That would get the x alone. So our goal is, again, that we're trying to get the x alone. So here we see this cancels out, leaving us x is greater than 9 plus 4 is 13. Now, we know how to represent this solution.
I see it.
We're going to go ahead and write it both ways. Just because I want you to get into the habit of doing that. And so we know that this solution is not just a single value, so we can't just write down the values that this is correct for. So we always graph the solution. So here my starting point is what?
13.
13. Is it open or closed? Open. Now before we move on, there are two checks that we are going to do when we are solving inequalities. There are two parts of our graph. One is the starting point and one is the direction that we shade. So we have two checks that we can use to check both of those things. Both of them involve coming all the way back to the original inequality. X plus negative 4 is greater than 9. And we're going to do the other check over here. We'll talk about this one in a second. But we're going to come all the way back to the inequality. This is the original inequality. So for the first check, if I want to check my starting point, I want to plug in that value for the starting point. 13 plus negative 4 is greater than 9. 13 plus negative 4 is 9 is greater than 9. So actually, the first check is really just checking that things are going to be equal. If you ever do the first check and things actually don't come out as equal, then something is wrong with your first check. That tells you that your solving of the equation is wrong. So the first check, taking the original inequality, plugging in your starting point, and making sure that both sides come out equal. Easy. So after that, we want to come back and finish graphing this. So we have x is greater than 13, so we need to decide which direction we want to shade.
This side. Right side.
Is that to my left or to my right, Judea?
Right.
To my right. So Judea wants to shade over on this side. And so Judea is saying that all of these values over here are part of this solution. Any value over here would make this inequality statement true. So the way that we're going to check that that's the case is we're going to take one of those numbers and we're going to see if it makes the statement true. So I'm going to take 15. I'm going to plug it into my original inequality. It should have been a negative 4. 15 plus negative 4 is 11. Sorry, this should have been a positive 9 if we went back to the original inequality. And we get that 11 is greater than 9. Is 11 greater than 9?
Nope.
11 is greater than 9, so that means that we have shaded the correct direction. So notice the order that I do this in. I solve the equation, or excuse me, I solve the inequality. Then I check the starting point. Then I finish graphing. And then I check which way I shade it. Because if the starting point is wrong, then it doesn't matter which way we shade, it's still going to be wrong. Okay, so the goal here is that we have to go ahead and do this check, finish graphing, then do the second check. Doing the checks is going to be part of your work. It's going to be part of your test. If you don't do the checks correctly on your test, then you're going to lose half of your credit. So what usually ends up happening at the end of this period and on the test is that somebody says, well, Mr. Boots, what am I supposed to do for this check? So let's make sure that we are all crystal clear that we know what we're supposed to be doing for our two checks for solving inequalities. Somebody with a raised hand, remind everybody and summarize for everybody what we do for the first check and what we're looking for to happen on the first check. Okay, everybody please track Sunny.
On the first check, you're seeing if like you pick the number that's you get from simplifying an equation first, and you plug it into the original equation, changing the sign, that's the sign there to an equal sign. And then you see if both sides equal each other.
Perfect. So he's saying we're taking that starting point that we found after solving the inequality, we're plugging it in to see if both sides come out equal. What is the second check? Somebody with a raised hand. What do we do for the second check? This is the trickier one that I think a lot of people get confused with. Please track Ian.
For the second one, we're going to start with the first equation, and we're going to plug it into the numbers.
What number?
In this case, it was 50.
So why did we choose 15? Why not 11 or 12?
Because x plus 4 is greater than 9.
What made me choose 15 here? Somebody else with a raised hand, help them out. What made me choose 15? Why did I choose 15? Iron. Manuel, why did I choose 15?
Because there is a sign that means it's going to be greater than 9, and then on that number 9, it's 13. So 13, well, 15 is going to be greater than 13 and 9.
Okay, so a lot of you are missing the point here. So the point is, it's looking at, I shaded this over and I said that all of these numbers were part of this solution. So I'm checking that one of these numbers that I shaded over is actually part of the solution. Because as long as one of them is, if my starting point's in the right place, then everything else shaded over here would be part of the solution. So it has nothing to do with going back to the original and everything to do with what we shaded. So the reason I picked 15 is because it was a number that we shaded over and said was part of the solution. I could have picked 14. I could have picked 16, 17, 18, 19, 20. I could have picked 100. I could have picked 1,000,000. It doesn't really matter what number it is. It's just as long as it's something that would have been shaded over. So going back to what Ian said, the second check is taking one of those numbers that we shaded over and we said was part of the solution and plugging it into the original inequality. Whatever statement we get should be true. Are there any questions about the two checks? Judea.
I have a different question, but it's
Jalen.
involving, it's involved, oh.
When you like, so you get the second number, you just randomly pick a second number.
I randomly picked a number that was shaded over. I wouldn't pick any numbers over here because I didn't shade over them.
Oh. So usually it would just be like, so like two numbers from the number that you picked.
I could have picked any number. I could have picked 14. I could have picked 18. I just happened to choose 15 because I just happened to choose 15. It was shaded over. I just picked a number that was shaded over.
Next one.
Judea, question.
When you do a problem and then the X is on the other side, can you flip it? Like, oh.
All right, so let's look at the next problem.
You don't forgot to look first.
What is the first thing that we need to do if we're solving this just like it's an equation?
You're supposed to turn it to a negative.
Andrea,
Turn it to a negative.
you change switch.
Turn it to a negative.
Then what is the next thing that we would do? Viviana. Add positive 3 to both sides. So negative 3 plus 3 is greater than x plus negative 3 plus 3. Now, something that a lot of you end up doing right now is a lot of you get really used to, and you've been doing this with equations for a long time, if you see the x on one side of the equation, you just immediately just switch it over to the other side, and you would do something like this. This is a completely different equation. Excuse me, a completely different inequality. Because I see that instead of the inequality symbol opening up to the negative 3, it's now opening up to the x plus negative 3. So this doesn't work. You can't just flip it around like that. If you do flip it around, and I'm okay if you do flip it around, you also have to flip around the inequality symbol. So it's still opening to the same thing. I don't suggest you do that. It's just another place for you to make a mistake. So as I continue to solve this, I get x plus 0, that's 0, and I get negative 3 plus 3, which is 0. So I get this inequality, 0 is greater than x. So getting back to Judea's question that she had earlier, so the question is now, if I want to graph this, a lot of us are more comfortable turning this around. We can turn this around, we can write it both ways. We can write it as x is less than 0. That makes more sense for a lot of us when we're getting ready to graph it. So I think that my starting point is 0. I want to check my starting point by doing my first check. So what should I do for my first check? Iron. For my first check, I want to check my starting point. What should I do for my first check? Maria.
Negative 3 is greater than x plus negative 3.
And what do I want to plug in for x? 0. I want to plug in my starting point. So I believe that 0 is my starting point. If this is indeed my starting point, this is actually going to come out equal.
Yep. I see.
So one thing that I find a lot of people doing when they do checks like this is they don't actually pay attention to what they're doing when they're checked. They just assume that their answer is right, and they kind of put their brain on autopilot. And sometimes they do stupid things in their check, like, don't pay attention to good dates and bad dates, or don't take the sign of a larger number. And the reason they do that is because they want so badly for their answer to be right that they just don't actually think about it. They're just assuming. Okay? Yes, Judea.
Oh, that's the equal sign. Is that an equal sign?
Yes, that is an equal sign. So for the first check, we're actually looking to see if we plug in our starting point, do they come out equal?
Oh,
That's for the first check. For the second check, after we've shaded, so Judea, which way do you want to shade here? To the left or to the right?
the left.
Judea wants to shade to the left. So I'm saying that everything that I'm shading over is part of our solution to this original inequality. So the way that I'm going to check that all of these numbers are part of the solution is by doing what? Jalen,
By checking it
checking it how?
on the picking a different number, or
Okay, what number would you like to pick?
I would like to pick -4.
Okay, so he's coming all the way out here. He's coming out to -4. That's a number that we've shaded over, so that's fine. And what are we going to do with that -4, Jalen?
We are going to put it, we want to plug it in for x and solve it.
Yep, so we're going to put -4 in for x, and then we're going to see what happens with the two sides. So this is going to stay -3. -3 is greater than -4 plus -3. That's like signs add. Take the sign of the larger number is -7. -3 is greater than -7. I would rather owe somebody $3 than owe them $7. Yes, that's true. So that means that we've shaded the correct direction. Okay. All right, next one. What's the first thing that I should do with this? Justin, you've changed switch. What's the next thing that I should do with this, Carson?
No. Add a positive to the negative.
Add a positive what to both sides?
-5. No, positive 5.
Positive 5 to both sides. -5 plus positive 5 cancels out. That's x plus 0, so that leaves just x is less than or equal to 14.
Yep, I got that.
So when we say our starting point is 14, how do I check that our starting point is indeed supposed to be 14? How do I check that 14 is indeed supposed to be our starting point? Raven. So she's coming back to the original inequality. She's plugging in 14 for x. And we know in the first check, if our starting point's right, these are actually going to come out as equal. 14 plus -5 is 9. So that is indeed our starting point. Now, is this open or closed? Closed. And now we need to shade. Gerson, which way do I want to shade? Left or right? Gerson wants to shade to the right. So we're going to check that by doing what? Viviana. Okay, what number should we pick to check what Gerson has decided to shade? Okay, we're going to plug in 16. We're going to get 16 plus -5. It's less than or equal to 9. 16 plus -5 is 11. Is less than or equal to 9. Is 11 less than or equal to 9? Kip yes or kip no. Is 11 less than or equal to 9? No, it's not. So what does this tell us? That our shading is incorrect. So we need to undo our shading. And we need to try the other way. I'm going to leave this check here as part of my work. I'm just going to mark it out. And so now I need to check something on the other side. So I'm going to pick 12. 12 plus -5 is less than or equal to 9.
7.
7 is less than or equal to 9. Is 7 less than or equal to 9? Kip yes or kip no. Is 7 less than or equal to 9? Alright, so that tells us that we've shaded the correct direction. Okay. And we'll do one more. What do I need to do to solve this inequality? Brenda.
Ouch.
Brenda, was that particularly helpful getting x alone? I ended up canceling out and getting a 0 on the left-hand side, but I still have x plus 4 over here. So was adding -3 to both sides really helpful? No, so what do we need to add to both sides? Relax.
You don't want me to relax?
So let's see, -7 plus 3 is less than or equal to x plus 7 plus -7. -7 plus 3 is -4. It's less than or equal to x.
How about a
7
negative?
plus -7, that's 0, so that actually cancels out. Gives me -4 is less than or equal to x. Did that get x alone, Brenda?
That's -4.
Yes, so that's good. So we want to go ahead and write this the other way, the way that most of you are more comfortable with it. So I'm going to turn it around. X is greater than or equal to -4. So I believe my starting point is -4, but how can I check that? How can I check my starting point, Jalen?
You could, you could like, wait, what do you mean by that?
How do I check that this is indeed my starting point, -4?
Oh, because it's on like the start of the problem it says -4, and then that's the only number you have. So, and then x is a variable, variable, and it's not a number yet.
Emmanuel.
Wait.
How do I check this? How do I check my starting point? How do I do my check, Jadea?
Add 7.
What am I doing in my check?
Adding a positive 7. Oh, no.
Ian, what am I doing in my check?
You're plugging in the -4 to the equation.
Going all the way back to the original inequality and plugging in -4. So I had 3 is less than or equal to x plus 7. I plugged in -4. If this is true and this is indeed my starting point, then they should come out equal. -4 plus 7 is 3. So I know that's my starting point. So is it open or closed? Sage? And Sage, which direction would you like to shade?
Damn, Ronnie, shut up.
I hear Sage saying that she wants to shade it to the right. Sage, how are we going to check that? How are we gonna check that Sage shaded this correctly?
Somebody on the table. You know your name, baby, shut up.
Kevin, so we're gonna go all the way back to the original inequality and we're going to plug it in. So we're taking a number that we shaded over and we're plugging it in. Three is less than or equal to 5. Kip yes or Kip no. Is 3 less than or equal to 5? Okay, so that means that we shaded the correct way.